Okay, so I wanted to just do an example real quick to show you how you're going to work through this type of question. This is from the second section in your Delta Math assignment. So you're being asked to find the area of all this green space. The weird thing with this is that the graphs actually cross. And so the graph that is above changes in each region, right? So it does say to use a calculator to do this. So you're going to go to Desmos. The first thing that I did is I graphed each function. I went ahead and threw in the boundary lines, which were 0 and 1.25. Again, you can tell that 0 is the beginning point and 1.25 is given, so I threw those in. The next thing you need to do is recognize the area that you're trying to compute for as two different regions. So there's this first section here, and then there's this second section over here, and we have to compute each separately, okay? So what I want to do to find the area of this space is I want to say, let's find the area under the curve or between the curves from 0 over to this intersection point, okay? So it looks like if you go over to the intersection point, they cross at 0.4538, okay? So that's super important to know. So make sure you understand or jot it down. These things cross at 0.4538 on the x-axis. So your first integral that you're going to make is going to be the area between the curves from 0 to 0.4538. And then remember, it's top curve minus bottom curve. So in this region, maybe go back to Delta Math. In that region, what's 0.45 or what's on top? So what the black curve is the one that's like kind of like a parabola, the squared one. So you would be putting that first. So you would go negative 2x squared minus 1.5x plus 5. That's the curve on top. Minus the 2x plus 3, because that's the curve on bottom, dx. You're going to get an answer, okay? Now, did you know that you can actually do antiderivatives if there's an integral or an interval? You can do that in Desmos. So you can do your little antiderivative from 0 to 0.4538, I think. 0.4538. And you can type your equations in. Now, here's the other thing. I've already got the first one called f of x, and the second one is called g of x. So I should be able to just type f of x minus g of x. If it'll let me, parentheses dx. There you go. There's the area. So that's your first half of the shaded space that you needed is 0.4849. Okay, now we're going to do a second antiderivative. And that second antiderivative is going to represent this space. Okay, that's going to represent this space. So you're going to do the same thing, except this space is going to go from 0.4538 to 1.25. Okay, so I need to change my intervals, 0.4538 to 1.25. And what curve's on top this time? The curve that's on top this time is G, and the one that's on bottom is F. And you're going to have that area, and you're basically adding them together, and you have your solution.